Remember that the properties of a square and a rectangle are similar because a square is a special type of rectangle. A rectangle must have opposite sides that are parallel, adjacent sides that are perpendicular. Opposite sides are equivalent and adjacent sides are not equivalent. And there's also the square, which all sides are equivalent. That makes all four interior angles 90 degrees. Now we're going to construct a rectangle. We're going to start by creating a segment AB. And now we're going to construct a line that is perpendicular through point B. There we go. And now we're going to create a point that's on that line. We'll call it point C. And we're going to now use the parallel line tool. That's going to go through point C, parallel to segment AB. We also need another perpendicular line that goes through point A, perpendicular to AB, which makes this line and this line also parallel. So now the intersection of these two lines, we're going to use our intersect tool, and we've created intersection point D. Now we're going to create our polygon, A, B, C, D. Remember to close it. And notice that you can make this picture prettier by hiding particular objects. We can hide these lines here that we constructed. And now we've got our rectangle here. Notice this point cannot move. This point, the only thing that it can do is make this longer or shorter. This point, you can turn or move it here, but it still is a rectangle. Now let's create a square. We're going to start out the same way as the rectangle. We're going to start out with the segment AB. However, one difference is we're going to give it a length. I'm going to make mine 5 units long. And now we're going to need our perpendicular here, but we have to make sure that it's the same distance to B as A is to B. So we need to construct a circle to do that. Center at B, and it goes through point A. Now what we can do is we can also create the perpendicular line that goes through point B, perpendicular to point A. And this point right here, where those two intersect, is going to be the same distance to B as B is to A, and it will also be perpendicular to segment AB. Now, since I don't really want to name both of these points here and here, we're not going to use the intersect tool. We're just going to use this point tool. And notice that it says circle C and line G is going to be the point of intersection when I hover. So I'm going to call that point C. Next thing I'm going to do is I need to create a perpendicular here. Notice it doesn't really matter what order the circle and the perpendicular go in, because either order they're going to end up in the same place. So this time I'm going to do my perpendicular through point A, perpendicular to AB, and then I'm going to construct my circle, center at A, and I want it to be a radius AB. Now this point of intersection is going to be exactly 5 units to point A, and it's going to be perpendicular, creating a right angle here. I'm just going to need this one point. Now I can create my polygon. This is going to be polygon A, B, C, D, and do not forget to close your figure. Now to make this more usable, I can hide my circles and my perpendiculars. and then I can do the move test. When I move this one, notice that the sides are not changing in length. This one cannot be moved, this one cannot be moved, and this one moves the entire figure. Next, we are going to create a hexagon, and it's going to be a regular hexagon. This is going to be created with a lot of circles. Let's start here. Okay, I've got circle A that goes through B, and now I'm going to create a new circle with center B that goes through A. Then I'm going to use my intersect tool to intersect these two circles. Now I've got points C and D. These are going to be 2 points on my hexagon. Now the next thing that we need to do is we need to do a circle with a center C that goes through point A. So notice it also goes through point B. Next thing that we need to do is find that intersection right there. Now we don't want to do all the intersections, just this one right here. So we're going to hover and click. Now we're going to do a new circle with center D that goes through point A. Every time I'm creating one of these circles, the intersection is going to be equidistant. So that's creating my regular hexagon sides. The next one, we're going to go through center point E, and of course it's going to go through A. Find the intersection, label it, and now we have our 6 coordinates here. We've got C, B, D, F, G, and E. Now I already know that they're going to be equidistant. The next thing we need to check is the interior angles. So let's draw our hexagon. F, G, E, C, B, D, and back to F. And now we're going to hide the things that we do not need, like our circles, and point A we don't need anymore. Now, notice that we can move the hexagon so that it's larger or smaller. I'm going to make it like that so that I can have room to measure the angles. I'm going to measure this angle here, and it is 120 degrees. That means all the other interior angles should be 120 degrees as well. So far, so good. And we do have all interior angles are equal. And we also already know that all the sides are equal. There's 6 sides, so that makes it a regular hexagon. The next thing that we're going to construct is a triangle. We're actually going to create an arbitrary triangle. We're not actually constructing a triangle. Okay, we're going to be constructing the perpendicular bisectors for each of the sides. So there's a tool for that. It's not the perpendicular line tool. It's the one where you have to select 2 points so that it finds the exact center between those 2 points and then constructs the perpendicular from there. So I want to construct the perpendicular bisector for side AB, side BC, and side AC. and then we're going to find where those three things intersect. Notice that point D and point E are exactly at the same spot. That's because all three of the perpendicular bisectors intersect here. So now what we're going to do is we're going to construct a circle with this center that goes through each of the vertices of the triangle. Find my circle tool, and here we go. Now, this right here, we are calling the circumcircle of our triangle. Let's perform the drag test. No matter what I do with my three vertices, notice that the intersection of the perpendicular bisectors could be inside or outside the triangle, but it always circumscribes that triangle.